Hello, welcome to the class of Advanced Stats and Econometrics. In today's lecture, we are going to discuss stationary and non-stationary time series. So, a time series is basically a sequence of observation over equal time intervals. So, equal time interval can be per day, weekly, annually, monthly, quarterly, and so on. So, most economic time series in the level form are non-stationary. What do you mean by non-stationary? That means uh, their means, variance, covariance, something is not constant, or their distribution is not constant over different time periods. So it matters where how you are going to when you are going to measure it. Such series often exhibit an upward or downward trend over a sustained period of time. But such a trend is often stochastic and not deterministic. Regressing a time series, non-stationary time series on one or more non-stationary time series may often leads to the phenomena of spurious or meaningless regression. So what are the diagnostic tools? Time series plot. First is you can plot it and see the distribution, whether it is moving along a constant line or it is having some increasing or decreasing trend. Another is autocorrelation function, ACF, and correlogram. Correlogram will suggest if the correlation of the time series over several lags decay quickly or slowly. If it does decay very slowly, perhaps the time series is non-stationary. Unit root test. If on the basis of Dickey-Fuller test or augmented Dickey-Fuller test, we find one or more unit roots in the time series, it may provide a further evidence of non-stationarity. If after diagnostic test, a time series is found to be stationary but trending, we can remove the trend by simply regressing that time series on the time or trend variable. If the residual from this regression uh, then will represent a time series that is trend free. Autocorrelation function, ACF, and correlogram. ACF at lag k is defined as rho subscript k, that is equal to gamma rho upon gamma naught. Covariance at lag k upon variance. Use the Akaiki or Schwarz information criteria to determine the lag length. A rule of thumb is to compute ACF up to 1/4 to 1/3 the length of the time series. Test the statistical significance of each autocorrelation coefficient in the correlogram by computing its standard error. Alternatively, find out if the sum of the autocorrelation coefficient is statistically significant. Distributed as chi-square using Q statistics, where n is the sample size and m is the number of lag or degree of freedom. So Q statistics is equal to n times summation of p hat square k. K is from 1 to m, and this is distributed as chi-square. You can see the squares are there. So p hat square k, and you add it and multiply by n. N is the sample size and m is the number of lag. Unit root test of stationarity. The unit root test for the exchange rate can be expressed as delta, that is change in L ext, and you regress it with b1 plus b2 times t plus b3 times lext minus 1 plus ut. We regress the first difference of the log of the exchange rate on the trend variable and the 1 period lag value of the exchange rate. The null hypothesis is that B3, the coefficient of LEXT minus 1, is 0. This is called the unit root hypothesis. The alternative hypothesis is B3 is less than 0, that is negative. a non-rejection of the null hypothesis would suggest that the time series under consideration is non-stationary. We cannot use a t-test because the t-test is valid only if the underlying time series is stationary. Use the tau test, also known as the Dickey-Fuller test, whose critical values are calculated by by simulation and modern statistical packages such as eViews and Stata. So you are aware about eViews and Stata. They are a software package that is used for time series. Dickey-Fuller test, augmented Dickey-Fuller test. If the error term ut is uncorrelated, use the augmented Dickey-Fuller test. Add lag value of the dependent variable as follows. So delta lext is equal to b1 plus b2 times t plus b3 times lext minus 1 plus summation I is equal to 1 to m xi times delta lext minus I plus e epsilon t. DF test can be performed in three different forms. Random walk, that is delta lext is equal to b3 times lext minus 1 plus ut. Random walk with drift, that is delta lext is equal to b1 plus b3 lext minus 1 plus ut. And random walk with drift around a deterministic trend, that means delta lext is equal to b1 plus b2 t plus b3 times lext minus 1 plus ut. Co-integration and error correction models. Co-integration. There is a unique case where the regression of the non-stationary series on another non-stationary series does not result in spurious regression. This is the situation of co-integration. If the two series have stochastic trend, they are non-stationary. A regression of one on another may cancel out the stochastic trend, which may suggest that there is a long run or equilibrium relationship between them, even though individually the two series are non-stationary. Keeping in mind that the unit root and non-stationary are not synonymous. A stochastic process with deterministic trend is non-stationary but not unit root. So a stochastic process with a deterministic trend is non-stationary but not unit root. Test of co-integration. Anger-Granger and augmented Anger-Granger test. In the context of testing for co-integration, the Dickey-Fuller test and augmented Dickey-Fuller test are known as Anger-Granger EG and augmented Anger-Granger AEG test, which are now incorporated in several software packages. Shortcomings of EG methodology. If you have more than three variables, there might be more than one co-integrating relationship. Once you go beyond two time series, we will have to use Johnson methodology to test for co-integrating relationship among multiple variables. Unit root test and co-integration test. Tests for unit root are performed on a single time series, whereas co-integration deals with relationship among a group of variables, each having a unit root. It is better to test each series for unit root, as some of the series in a group may have more than one unit root, in which case they will have to be differenced more than once to make them stationary. If the two time series y and x are integrated of different orders, then the error term in the regression y and x is not stationary, and this regression equation is said to be unbalanced. On the other hand, if the two variables are integrated of the same order, then the regression equation is said to be balanced. Co-integration and error correction mechanism. Granger representation theorem. If two variables y and x are co-integrated, the relationship between the two can be expressed as error correction mechanism. ECM postulates that changes in the dependent variable depend on the changes in the independent variable and lagged equilibrium error term ut minus 1. If this error term is 0, there will not be any disequilibrium between the two variable, and in that case long run relationship will be given by the co-integrating relationship. But if the equilibrium error term is non-zero, the relationship between the two variable will be out of equilibrium. For multiple time series we need to use vector error correction model, VECM. And the reference for all this is a book titled Econometrics by Example, second edition, Palgrave Macmillan. Author is Damodar Gujarati. That's it for today's lecture. Thanks.